Yeah, guys, welcome you all for the today's session again. So today I'll be taking up the next topic, which is the types of firewalls. Because in the last session we had completed about the introduction to the firewalls. So today we'll be taking up the next session, which is the types of the firewalls. So if any one of you missed out that session, so you can also make it your free time to view this introduction to the firewalls. So because this is the topic which we are covering today, that is the extension of the topic which is introduction we had covered in the last class. Okay. Now let's come back to our current topic, which is types of firewalls. See, under this types of firewalls, there are a lot many ways we usually classify the firewalls. One of the best example I can say, in the last session we had something like firewalls can be a software firewalls and also the hardware firewalls. Then later the people came up with the firmware firewalls as well. That's the one type of the classification I can say, where you have software firewalls, hardware firewalls, and also the firmware firewalls. Then later there is a one more type of classifying the firewalls, which is with respect to the network, whether your network is a wired network or wireless network. Again, so again there are the classification, because the firewall which works for the wired routers, that's wired connecting devices, and also the wireless routers are not same, which makes some difference. So there again there is a difference. Again, the firewalls has to be applied in which layer, whether it has to be applied on the network layer or transport layer, or it is in the application layer of your TCP/IP. So again, there based on that, again we have the types of firewalls. So like that, based on the scenarios, based on the requirement, based on the specific perspective, there are the different types of firewalls we have. But today we'll be dealing with the basic classification. We call it as a principal classification, principal types of the firewalls. So that is what today's concept, where we are going to see this principal types of firewalls. So among the n number of classification, as I already said, so today we'll be taking up the four different types of firewalls. So which are packet filtering routers firewall, application level gateway firewall, stateful inspection firewall, and circuit level gateway firewall. This, among all these four, that's what I say: packet filtering, application level gateway, and also the stateful inspection firewall, and a circuit level gateway. Among these four, you one difference or one common point you can identify that. So which, what is that common point I wanted you to identify is yeah. So here you can see the packet filtering router. I want you to observe this. This is packet filtering router, whereas application level gateway. Again, the fourth case also you can observe, this is circuit level gateway. So why I am stressing upon this, in the sense, the router functionalities which are occurring at the router level, it is at the router level. So in turn, where in which layer the router will be there, router covers till the transport layer. Then again, when you take up the gateway, which will be in the application layer, so it will cover till the application layer. So like that, so that's what I say, based on the feasibility of where exactly will be applying the firewall. So that is the one of the classification which I already said. So now let's take up each. So even before that, as a just for a revising point of view, so this is a general depiction of the firewall system, where you have your own internal, this your network, I call it as this is your internal network, which is protected by you. Or in the other way, let's say that you want to protect your internal network. This is what your internal network, and this is the external network. This is the external network which does not belongs to you. But even then there is a necessity of communication between your internal network, which is protected, and also the external network. You don't know whether it is protected or not, whether you trust it or not. So because it's external, it is not, it belongs to you, it is not under your control. So there, if there is a necessity of communication or exchange of messages between these, which has to, where we are in between that we are building a firewall system. That firewall system which actually give you the security mechanism, which is something like entry level checking process. At this point of time, so I'll say that there are the four classification we are going to take up for today's class. Let us take up first one. So when I say that first one, just packet filtering router, as the name itself specifies, remember this has I want you to observe this. I want you to understand this complete process based on these three keywords itself. That is enough, which is packet filtering router. So it means to say that where it is applied, in the sense it is applied at the router. In turn, what is the router? Which is for which you will be having your private network, your secret network, or your private network, or your LAN is connected to that router. So when whatever the request which will pass through, so which are the request or the response messages which has to cross through that router. So whatever you send and whatever you about to receive into your network, which has to pass through this router. What about then? That's what I say. It is applied at the router level. Then it is packet filtering. What I'm saying, that just passing either what you are sending and whatever you are receiving at the network layer, the data which will be in the form of what? Packets. Those packets will be filtered. Those packets will be filtered as something like, which are all the good packets, which are all the bad packets. In the technical way, let's say that positive packets and the negative packets, which are all the packets used to be discarded and which are all the packets used to be forwarded. That kind of filtering process has to be taken care by the packet filtering router firewall. The firewall which is applied, or firewall which is established at the entry level router. What is the functionality? It has to keep classifying. It has to keep classifying the incoming packets. So which are all the packets are negative packets, are harmful packets, and which are all the good packets, which are successfully you can forward them. So in that perspective, I say that this packet filtering router, it is something like firewall which is adopted, or firewall which is established in the entry router, which is applied at the entry router. The complete functionality of the firewall which will be taken care by this router itself. And what is, I say that complete functionality, what is the functionality? It is nothing else than the filtering of the incoming packets. What is that incoming packet? What is that filtering? So you just make sure that whether that packet is a good packet or the bad packet is going to, whether it is going to harm your network, or it's just a safe packet. It's a safe packet. So based on that, you make the decision whether you want to discard that or you want to forward it. Whether you want to discard it or forward it. So till now I am saying that it is going to do the some kind of action as discarding or forwarding. But basically based on what? Based on what it is going to make a decision, in the sense it is based on the set of rules which are already predefined. The set of rules which are already predefined, based on those rules itself. Based on those rules itself, the router is going to make the decision whether that packet is a good packet or it is a bad packet. Based on that, you decide whether the packet has to be discarded or forwarded. So only we say that the packet filtering router that applies set of rules for every incoming packet. For every incoming packet, it applies that. Then once after it applies the set of rules, then it makes the decision whether it has to forward the packet or discard the packet. Whether it has to forward the packet or discard the packet. That kind of filtering is going to happen in the incoming router or the packet router. So that is the simple functionality of the packet filtering router. And where exactly it is applied, in the sense you can observe this, it will be applied in between the internet layer to the transport layer. So between this internet layer to the transport layer, when you are before I continue, can anyone respond? Am I audible? And also PPTs are visible. Is there any disturbance? Anyone of you can you respond? Yes. Am I audible?
Yes, sir.
And is there any disturbance?
No, sir.
Fine. See, try to understand in the other way. In a general means, non-technical way. Let me say that. So I hope you already studied or came to know something like these are the layers. These are the layers in the. These are the layers in where? These are the layers of TCP/IP, not the OSI layers. Remember, this is the TCP/IP where so, and among these layers, I hope you know that application layer will be considered as what? User interface layer. Whereas this physical layer will be considered as what? Network interface layer. So from other device, whatever it is received to your device, first it will enter through the physical layer. First it will enter through the physical layer, and by the time it internet layer, the data which is in the form of IP packets or the packets. Then it will deliver to the transport layer, then deliver to the application layer, then deliver to your user, which is the actual my user mission. That is what I say it as application layer. Application layer is the user interface layer, which is the actual, which is received to the actual device, I can say in the non-technical way. So what I'm saying, whatever the data which is received, whatever the packet which is received through the physical layer, when it is passing through the internet layer and the transport layer, this is where the filtering is happening. Remember, this is where the packet which is filtering is happening. If the packet is found as false or something which is bad packet, that packet will not be delivered to the application layer at all. It will be dropped at the transport layer itself. It will be dropped at the transport layer itself. It will not be given to the higher level layer at all. When it is not given to the higher layer, which is the higher layer, which is application layer, when it is not given to the application layer, it will not given to the user at all, because that particular packet is found harmful, that is rejected or discarded. So that is a simple process which will be taken care by the firewall in the firewall which is applied with respect to the router in the transport layer, where it will be classifying the packets which will be incoming from the network layer to the transport layer. Because so that is like that classification, I can say that classification which will be happening based on the set of rules. Now let's see, till now I am saying the set of rules, but what are those rules? What are those rules which will based on which that packet filtering will be happening in a sense? And also before you can observe or before you can think about the rules, again I repeat, now I am talking about both the network layer and also the transport layer. Network layer in the other way you may also call it as internet layer in the TCP/IP model. Usually we call it as network layer in the OSI. So you may also call it as internet layer in the TCP/IP. So I'm talking about the packet which is forwarded from the from network layer, which is from the internet layer to the transport layer. There that classification is happening. So only that data which is in the form of a packet, and whenever you want to transfer that data in the form of packets, you do make use of the IP network. So only you call it as a IP packet. So if at all if you say that there is a IP packet, for which definitely there will be IP header, that also I hope you know that. So IP packet do have the IP header. That IP header can be IPv6 or IPv4. That let's not bother about that right now. It may be IPv4 or IPv6. Now what I am talking in the sense that classification or the differentiation of the packets which do happens based on the set of rules. Now let us see what are those rules. So here you can observe these are the few set of rules, or in the other way say that rules are made based on these 5 points or 5 scenarios. So I hope you know this. IP address, source IP address and the destination IP address. Source IP address and destination IP address, and very, very, very importantly, source and destination transport level address. What is the transport level address? It is nothing else than the port address. I hope you know this as well. So because if you remember in the data link layer, you do make use of the MAC address. Next, network layer or internet layer IP address, logical address. So again, next layer transport layer port address, which you may also call as process communication port addresses. Then application layer you call as specific address. So here, as I am talking about where the classification is happening with respect to the network layer, or when you are passing the packet from network layer to the transport layer, that is where the classification is happening, or the filtering is happening by the firewall. So you need both the type of addresses. The address which will be used in the network layer, which is IP, and also network address which is used in the transport layer port. So do make use of today and 4 different addresses. It has 4 different addresses. Okay. So the destination, so destination port. So there will be 4 addresses. So IP, destination IP, so then again port numbers. So then again, very, very importantly, IP protocol field. This IP protocol field, which varies with respect to what exactly this IP protocol field in a sense. if you remembered the header format of the IPv4, if you remember the header format of the IP header, so there was something like protocol field. If you remember, there was a protocol field in the IP headers, which is something like which is the transport protocol which will be implied with the IP packet. That protocol, it can be, what are those protocols? In the sense, it can be TCP, UDP, or it can be SCTP, which is TCP, transmission control protocol. So the next is what? UDP, which is nothing else, user datagram protocol, or it can be SCTP, which is stream control protocol, stream control transport protocol. So your IP packet might have used, so even if you don't understand about the SCTP, I hope you understand with respect to the TCP and UDP, if I am not wrong, because you might have know about the TCP and UDP in a clear and simple way. As such, if you want to transfer your data in the with respect to connection oriented service, you do make use of TCP. In that case, IP must be included with the TCP. Whereas if you want to transfer the same packet in the connectionless case, so you don't need TCP, you need what? UDP. Such kind of. So in that way, your IP packet is making use of which protocol of the TCP, which protocol of the transport layer. So I repeat, your IP protocol must make use of any protocol of the, or your IP packet must make use of any protocol of the transport layer. So which protocol of the transport layer will be used with your IP packet? That is what your IP protocol field. That's what IP protocol field. The last it is again interface. So this interface will come to the picture when you make use of the multiple ports. So what is that multiple ports in the sense? So per suppose if I am doing with respect to one-to-one communication, that's what simply say that point-to-point protocol, just one-to-one. In such case, you don't need multiple ports. So there will be only one port, which is something like whatever it will be transmission, which is happening, which is one-to-one. But whenever you have a multiple, something like when I am sending to the multiple devices or something like I may be broadcasting or I may be multicasting the data. In such case, that's what whenever it is not point to point, when it is multi-point or multicasting. In such case, you can't expect to have a single port. You may be having a multiple ports. In such case, there is a necessity of having a multiple interfaces. When you have multiple interfaces, which is the actual interface we are dealing with? Which is the actual interface you are dealing with? That is also very important. So that based on these filtering rules will be formed based on these. So am I clear till here? Any doubts? Anybody, any doubts till here?
No doubt, sir.
Now let's see that, as I said, that the filtering rules will be formed based on any of these what I say parameters. Then now the actual process of filtering will happen in the router. So that is to classify that whether the packet has to be discarded or forwarded. Whether the discarded has to be whether the packet has to be discarded or forwarded. So that is based on these scenarios or these parameters. So that's what I say. Based on that, you will come to know whether the packet has to be discarded or whether it has to forward. That is what do you mean by discard? So it is prohibited because it is not allowing, or it is not in the other way say that the packet which is not able to it is not up to the mark of these rules, or it is not satisfying these rules. In such case, the packet will be discarded. If the packet could able to satisfy these rules, then it will be forwarded. That is what permitted into your network. So that kind of simple classification is going to happen. Our filtering process is going to happen at the entry router level, and that classification at that filtering is happening with respect to the IP packet. So only it is packet filtering router. Firewall is working in the router. What it is doing? It is what? Classifying or filtering whether which are all the good and which are all the bad. That's what it is, filtering process. So only filter at the router, and filtering what? It is the IP packet. So only the name it is packet filtering router. So that's the first firewall type we have taken up, and we have simple advantages and the disadvantages of that. packet filtering router. So it is something like coming to the advantages. So it's purely with the, you can have your own packet filtering router if you have your own router. So it doesn't cost much. So it doesn't cost much, and also the whatever network resources are required are very very less. So only you call it as it is simplicity. It is a simplicity of using this firewall. Second thing is transparency to the users. So something like, whatever that log data which will be generated, that will be available to the user. So it is not, there's nothing like, the firewall has did it its job, but user I doesn't know how my firewall is working, because my firewall is working with the my router. So when my firewall is working with the my own router, so I can get in the complete log details of my own router. So that's what we say, that it is purely transparent to the users. And finally, it is high speed. Obviously that decision making, or the that filtering process, that's what firewall process can happen in a speed manner, or a faster, because I'm okay, that is happening, that decision making is happening only with respect to a small network, which is very less. The network size is very less, which is because that is mine, my own private network. So that kind of speed of that decision making or filtering or firewalling is uh, more. That's what high speed. Whereas there are the few disadvantages as well with respect to this. Very first and foremost thing, that as however I said, that it's purely happening based on the set of rules. When what if there is a packet which doesn't belong to any of the respective rules which you listed out, if what decision need to be taken care. So that kind of like, there are no I mean say, if suppose if there is an incoming packet which is doesn't belong to your rules, but it is not the false packet, it is not the bad packet. So what your filter is going to do? Obviously it will put into the bad packet itself, because it is not satisfying your requirements, it is not satisfying your rules. Just because your that packet is not satisfying your rule, so your filter will decide that it's a bad packet. So that's what it's purely works based on the packet filtering rules. Next is lack of authentication, which is like, what if, because no, earlier I shown the parameters here itself. So I shown with respect to the IP address, destination IP, source IP, all that. So what if you, is there a scenario of giving the security license? No, it is only, you are only checking based on these fields. What if somebody is spoofing, if somebody is spoofing, especially I hope you know that very well known attack which is IP address spoofing, or IP spoofing you call it as. So in such cases you cannot identify, because you are just checking with the source IP and destination IP. You are not bothering whether that source IP and destination IP is the actual one, or it is the spoofed one. So there is no mechanism here to check whether it is a spoofed one or the actual one. So that's what it bothers with the authentication. That's what I say, vulnerable to the spoofing. And the last one, so not only this, there are so many other security breaches also, security issues also, which are not taken care by the packet filtering router. So that's what few of the disadvantages. So again, possible attacks already I said, which is IP spoofing. Again, source routing attack, which is again one more thing. So if the, like in source node which is about to perform the routing, so as a part of source driven and also the table driven routing process, so if the source has to find out the route in case of source routing attack or a source routing process, if that source routing is implied, then it will be made to the find out the, or it will be made to authenticate the route which is not the actual one. So that's what you will be diverting, the attack which will be diverting or imposing to go to the different route. So which is source routing. Then again, tiny fragments. So what, whenever you will be sending the multiple packets, so there may be the necessity of sending them pieces. I mean, there is a necessity of sending the packets in the form of a segments as well. So whenever you will be sending through in the form of a fragments, or you call it as segments, so there is a necessity of using the offset values of the fragments. If such offsets are bigger or lesser, in the other way, let's say that if the fragment size is very smaller or bigger, so if the size of the fragment is bigger, it will be very easy, I repeat, it will be very easy for somebody else to know that. Because there will be say for example, if it is the total packet size, I'm just taking an example, if the total packet size is of 1000 bytes, and you are forming 10 fragments, where the size of the each fragment will be of only 100 bytes. So that you consider this situation. The second situation, you consider that same 1000 bytes packet you are dividing into the 100 fragments, where the size of each fragment is only 10 bytes. You see, for the filtering process, also the complexity or the work of the filter when it receives 10 fragments or when it is receives the 100 fragments, there it varies. So this tiny fragment attacks, it impose to create multiple fragments with the small size or the less size. So which is again one more drawback which we can say, which are not controlled or which are not avoided by using your packet filtering router. So here is a simple example. So this is the simple example which is given as a part of your packet filtering. So here, if you see that there are the 5 rule sets. There are the 5 rule sets, a set of rules. 5 sets are there. So based on the first rule. So something like whenever this is what your host address and the port number, and this is what the incoming are the outsiders host address and outsiders port number. That's what I said, we will be dealing about both IP address and also the port number. So this is what I said as your own host device and your own port number, there is the outsiders. So if you get this is whenever you get this star, it is not something like null or it is not applicable. This is what the wildcard designator we called as. So in such kind of wildcard designator which is unknown, when you doesn't know, so from which port you are getting from, obviously you can't trust it. That's what this is what for that what is action is something like you don't trust those people. So such kind of packets will be blocked. This is what the action. So such kind of packets will be blocked. So then which kind of packets will be allowed? Something like when you know your IP and when you know your port number, it is something like you are sending to somewhere. In such case, you are just something like you are seeking some kind of connection. So that can be allowed. So you may not understand in detail about that. Just try to understand in a simple as an example perspective. Again, you can observe this in the rule set B. When you doesn't know any IP, any port number, so obviously this kind of packets, it's something like you received one packet which doesn't have any address, and you don't know who has sent you, and where it has to be, where it is supposed to go. In such case, even that those kind of packets will also be blocked. So that's what these are this is just examples I'm just showing you. So like this, there is a classification or the having a decision making. That is what a filtering which is going to happen at the router level. So whether it has to allow the packet or it has to discard the packet. So that's a simple example. Next, let us take up the next example, which is the next type of firewall, which is stateful inspection firewall. See, this is, I can say it as this is an extension of the previous, which is packet filter, because that packet filtering is also going to happen in the router itself, whereas in this stateful inspection firewall, this is also applied with the router itself, not in the gateway. Remember, this is also applied in the router itself. But even then, what is the major difference you can find out in the science, or what is the major extension you can have in the science? That's what I repeat, this stateful inspection. It is something like, what is that stateful inspection? In the sense, you are going to check the state of the packet. Let me be even clear, because in the packet filtering process you are only bothering about the IP address and the port numbers, but you are not bothering about which connection you are getting from. You didn't bother about the which kind of connections you got it from. So that will be taken care in this stateful inspection firewall. So that's what in this example also, just a simple example. This is I call it as a screening router. That's its functionality is to check for the connections. So its functionality is to check for the connections, whether it is a TCP connection or is it a UDP connection, that you have it in a separate directory. Based on that connection, so you decide So whether you are getting from the authenticated connection or unauthenticated connection, are you getting from the safest connections, or you are getting from some other connection which is not safe? So in a simple means, I'm telling you that this stateful inspection firewall will also, or I mean say, it will be performing as same as the packet filtering itself, but it is doesn't bother about only the IP address and the port number. It also bothers about the connections, from which connection I'm getting from. So the input connection, from which connection I'm getting from, that is also will be taken care in this stateful inspection firewalls. So but it is also applied in the router level itself. So as it is applied in the router level itself, so it also bothers about the classifying the packets which will be incoming from the network layer. Again, already I said, again I'm repeating. So do remember, you are talking about in the interface between the internet layer to the transport layer. You received some data from other device to your device through the physical layer, and it has to pass through the network layer, internet layer, then transport layer. So it has to pass through like that. So in this transport layer, I said that packet filtering process will be happening between this internet and transport layer. That packet classification is to happen. Now I'm talking about this stateful inspection, which will also taken care about the connectivity. But when I talk about the connectivity, in the sense, connectivity will not be there in the application layer or the transport layer, I hope you remember, which will be there with the physical layer itself. That's what I said earlier. Physical layer is the one which is network interface layer, which is from through the physical layer itself, actually the network will be connected or interfaced. So which connectivity is that? Or however I say, stateful inspection, where you will be inspecting the connections, as will be inspecting the connections. That connections will be available with the physical layer itself. So at the physical level itself, you can get to know which is the kind of connectivity, which kind of connectivity you're dealing with. So that you will be recorded into this is what the separate, let's say that separate database, separate space which is to hold the information regarding the connections. So based on that also you can make a decision and what state files. So in the pack filter, so one of the example, if I want to shift it, see it is the example. However, there we had source IP, source destination port. The extra thing which I wanted to observe this is what connection state. Because so we expect that your connection, if your connection is proper, if your connection is secure, then whatever the data which will flow through that connection is also secure. It is not harmful. That is what the scenario of this stateful inspection. So in the other way, like you can also say that first you establish the connection. You make sure that the connection is secured enough. So if that you make sure that the route is secured, then you make the other packets to flow through that. So that is what stateful inspection. So as you want to establish the connection, so it is a means of one of the connection oriented service. So only you will be bothering about the TCP instead of the UDP. That's what stateful inspection firewalls. Yeah guys, any doubts in this stateful inspection and the packet filtering before I go further? Anybody has any queries? Yeah. Anybody has any queries? So till now we covered two types of firewalls, which is packet filtering we covered and stateful inspection we covered. The left out is application level gateway and circuit level gateway. Those two I'm going to cover right now, because that is those will be applied at the gateway level, whereas these will be applied at the router level. This will be applied at the gateway level. So only I'll be covering these two together: application level gateway and also the circuit level gateway. So before I go further, so any doubts? Anybody? Any doubts?
No, sir.
Okay. Okay, if there are no queries on this, then we'll see the application level gateway and also the circuit level gateway in the next session. So we'll see this application level gateway and circuit level gateways in the next session. What we covered is only packet filtering router firewall and also stateful inspection firewall. We covered only these two. We are going to cover this application level gateway in the and the circuit level gateway in the next class.